Good afternoon, class. We are looking at section 8.4, polar coordinates, equations, and graphs. This is part of chapter 8, further application of trigonometric functions, and we are going to finish it off. Part 2. We're going to graph r equals 1 minus cosine theta. So first and foremost, in general, r is equal to a times 1 plus minus cosine theta, or a times 1 plus minus sine theta. When a is positive, it passes through the pole, and it's a cardioid. It looks like a heart in essence. So we start with plotting points. We can go with any angle, but I like to go with the easy ones, common arcs that we know. For example, 0. If I put 0 here, cosine is 1, so 1 minus 1 is 0. Pi over 6. Cosine is square root of 3 over 2, so 1 minus square root of 3 over, this is 1 minus, okay. Pi over 4, square root of 2 over 2, so 1 minus that. Pi over 3 is 1/2, so 1 minus 1/2, which is 1/2. Pi over 2, cosine is 0, it's just 1. 2 pi over 3, negative 1/2, is the same as pi over 3 in the second quadrant, cosine is negative, so it's 1 minus negative 1/2. So this one is 1 minus negative 1/2. Let me actually write that. For this one, we get 1 minus cosine of 2 pi over 3, which is 1 minus negative 1/2, which is 3/2. For pi, let's just write it for pi too. 1 minus cosine pi, 1 minus negative 1. Just so you see, it's very easy to evaluate them. I'm going to erase my work in a moment. So those are the r, and now r comma theta. Let's write the pairs, everybody. Okay, so it's very easy to see the pairs and how we arrive at them. Now, what I want to do, I want to graph them here, and because it's small, I'm going to use 2 tick marks to represent one. 0, 0 is the pole, and we're going to use 2 tick marks. So I'm not going to go, for example, 1 minus square root of 3 over 2. Square root of 3 is about 1.7 divided by 2, and so forth. So let's go with the easy one. So 0, 0, 1/2 pi over 3. So first locate pi over 3. And we said 2 tick marks is 1. So 1/2 is 1 tick mark. Okay, 1 tick mark, that means the first circle, everybody. 1 tick mark. So this is 0, 0. This is 1/2, so pi over 3. The next one is 1 and pi over 2. Well, pi over 2 is up here, okay? And then 1, I'm looking at this one, everybody. 1, 2 tick marks, that means 2 circles up there. Okay, now 3/2 and 2 pi over 3. So let's find 2 pi over 3, it's this one, 2 pi over 3. And 3/2, 1 is 2 tick marks, and 1/2 is 1, so 3 tick marks. That means 3 circles, 1, 2, the third circle. Okay, the third circle, okay? And then 2 pi, so here's pi, or 180 degrees. 2, that means go with 4 tick marks. That means go with 4 circles, 1, 2, 3, 4 circles, okay? Now, if you put them together, looks like that. You're almost done. You can pick more points, but here's what I want to go over, class, and that is looking at symmetry. So because cosine is an even function, if we change it to minus theta, nothing changes. In other words, 1 minus cosine of negative theta is equal to 1 minus cosine theta. And so it makes it symmetric. with respect to the x-axis, if you will, the polar axis, okay? If in the polar equation r comma theta can be replaced by r comma negative theta, resulting in an equivalent equation, the graph is symmetric with respect to the polar axis. So just to give you an idea, just write here, class, meaning it goes like that. I hope you see that. Let me actually do a drawing. So symmetric, right? Goes like that. That's it. Okay. But in any event, if I want to plug in just as an example, 4 pi over 3. 4 pi over 3, just like 2 pi over 3 cosine is negative and it becomes the same, 3 halves. 3 pi over 2, this is 0, is just 1. 5 pi over 3 is positive 1 half. 1 minus positive 1 half is 1 half, and 2 pi gives you positive 1, 1 minus that is 0. So those are the ones, and then it's the graph. And again, as I mentioned, really use the fact that it's symmetric and you can easily see the graph. All right. We want to graph this. The equation 3 plus 2 cosine theta, and reminding you about the symmetry. Let's discuss the symmetry starting with replacing the theta with negative theta, everybody. As you know, it doesn't change because cosine of minus theta is cosine of theta, since cosine is an even function. And so the test works. It's symmetric WRT with respect to the polar axis. So number one, that. Now, with respect to this one, we are going to replace the theta with pi minus theta. We're going to use pi minus theta. And we're going to distribute, remember, cosine of alpha minus beta. Cosine alpha, cosine beta, plus sine alpha, sine beta. So we write 3 plus 2 cosine of pi minus theta is cosine of pi cosine theta plus sine pi sine theta. As you know, cosine pi is -1, but sine is 0. So you get 3 minus 2 cosine theta. And you look at the original one, are they identical? No, so that fails. That doesn't work. The last one is to replace the r with negative r. Okay. Is this identical to the original equation? No, so that doesn't work. Second one, you have to also check r and theta plus pi. So put theta plus pi, and I'm going to leave it for you to expand this. This one is cosine theta cosine pi, okay, minus sine theta sine pi. You can work on it to see that works or not, and that will fail too, because ultimately it becomes the same thing. So again, make sure you expand this just the way I did that. Cosine of alpha plus beta. This was cosine of alpha minus beta. And so let's go with graphing this, and we know that it is symmetric with respect, excuse me, with respect to polar axis. My apologies. So let's pick the easy points, everybody. 0, for example. Okay. Cosine of 0 is 1. 3 plus 2 times 1 is 5. Pi over 6, square root of 3 over 2. Pi over 3 is 1 half. 2 times 1 half. 1 and 3 is 4. Pi over 2. Pi over 2 cosine is 0, so just 3. 2 pi over 3. remember, is the same as pi over 3, but it's negative because it's in the second quadrant. So 3 plus 2 times negative 1/2. So you're subtracting 1. So you get 2. 5 pi over 6, 3 plus 2 times negative square root of 3 over 2. And pi, as you know, cosine of pi is negative 1. So 2 times that is negative 2. 3 is positive 1. So I hope everybody can see those. Okay, so the first point, 3 plus 2 times 1, 5 comma 0. So 1, 2, 3, 4, 5. Remember the way you locate that. Okay. I wrote a bunch of them. And I'm going to write the pairs. And I'm going to go with the easy ones. This one because number 4. Okay, pi over 3. We're going to locate pi over 3, which is, okay, sometimes they have it in degrees, there's 60 degrees. Okay, and 4. 1, 2, 3, 4. Okay. The next one is pi over 2. Pi over 2 or 90 degrees and 3. So this one. Okay. Two pi over 3. 3 plus 2 times negative 1/2. 3 plus 2 times minus square root of 3 over 2. This is one as I explained it. So let's write the pairs. This one is class minus 1. Okay. So we have 2 comma 2 power 3, 3 minus square root of 3, 5 power 6. And I'm going to go again with the easy one. So I'm going to locate 2 power 3 or 120 degrees, 120 degrees, and 2 tick marks, so the second circle. And I'm going to go again with the easy one, pi or 180 degrees, and the first circle, the first tick mark, right? And I hope you see the graph looks like this, and then it continues in the same manner because it's symmetric class. If you graph this, okay, the bottom looks identical to that because it's symmetric with respect to the polar axis. What about r equals 2 plus 3 cosine theta? In essence, we do it the same, okay? So let's plug in a bunch of points. And these are all easy points from 0 to 2 pi. We are going to discuss a couple of them. For example, 0, the cosine is 1, 2 and 3 becomes 5. Okay. Pi over 6, 2 plus 3 times square root of 3 over 2. Pi over 4, 2 plus 3 times square root of 2 over 2. Pi over 3, the easy one. Pi over 3 is 1/2. So 2 plus 3 times 1/2. And so on and so forth. Pi over 2 is easy. Pi over 2 is 0, so it gets 2. Okay. 2 pi over 3 is easy. Okay. 3 times negative 1/2. So 2 minus 3/2 is 1/2. Pi is also easy because it becomes negative 1, 3 times that, negative 3 and 2, negative 1. You can figure out the rest. Okay, just plug in. And here's the pairs, everybody. Also, quickly, we are going to do the test. If I replace the theta with minus theta, it makes no difference because it's cosine, right? So that makes it symmetric with respect to the polar axis. If you have half of it, the other works too, okay? So let's go with the easy one, 5, 0. So 0 is this. And you go with the fifth circle. Okay. So that one, the last one in essence. Uh, let's go with not those numbers. This is easy because it's 7/2, 3.5, and it's pi over 3 or 60 degrees. So look at 60 degrees. And 7/2, 3.5 between the third and the fourth circle. Let's go with this one, 2 pi over 2, pi over 2 or 90 degrees. Go with the second circle. Okay. First one and second one. Now, what I want to explain is, class, if we set this equal to 0, cosine theta becomes negative 2/3, theta becomes cosine inverse of negative 2/3, and there is an answer. Why am I working this out? I want to make a point that R, remember, when R is 0, that means the pole. So it does go through the pole, everybody. It does go through the pole, and here's the proof in essence. Now, here's an interesting one. -1 pi. Pi is this way, everybody. 180 degrees. If it was +1, would be here. But it's -1. So pi takes us to the opposite direction. So it takes us here, everybody. Another easy one is this. 3 pi over 2, it means here at the bottom, right? 270 degrees. And then it's 2, so the second circle. Okay. And so what we have, if you look at just this one, let me just graph this and then I erase it. So let me see what color works fine. So it really goes like this. Let me use a different color here. Red. Okay, it goes like this. Okay. Now the second part works out the same way. Okay. Let me use a different color. And it goes like that. Okay, because it's symmetric with respect to the x-axis, polar axis. Let me erase my work. Let me just show you their work and then erase mine. Okay, so this is when you do it with details. All right, rows. Graph the equation of R equals 2 cosine 2 theta. So basically, when we have multiple angles, whether it's sine or cosine, it becomes a rows. And the number of pedals, if you will, the pedals depend on this number. Okay, if it's even, doubles up. If it's odd, it remains the same. Okay, so let's actually look at it, see how it works. First, starting with the symmetry, we are going to replace the theta with minus theta, and when we do that, this doesn't change because you're dealing with cosine. Therefore, the test works and it's symmetric with respect to the polar axis. Let's go with the second case, replacing the theta with pi minus theta. When we do that, when we distribute, we get 2 pi minus 2 theta. And I hope you see that because the period for sine and cosine function is 2 pi, it's the same as minus 2 theta. This works out the same as minus 2 theta, and cosine is even, so it works the same as 2 cosine 2 theta, which makes it symmetric with respect to theta equals pi over 2. And if you have a situation, everybody, where you show the function is symmetric with respect to the polar axis, and theta equals power 2, then it is symmetric with respect to the pole. The function is symmetric with respect to the polar axis as well as the symmetric with respect to theta equals power 2. Therefore, it's symmetric with respect to the pole. In fact, you can try it if you want. Okay. Go through that, you can see that. In any event, let's plot pairs. Again, we're going to go with the easy part. And notice what we're going to do. I'm going to cut it into 4 pieces, just as we did with sine. So 0 to power 2, for example. And we're going to evaluate. So 0, as you know, cosine is 1. So we have 2. Power 6. 2 times power 6 is power 3. Cosine of power 3 is 1/2. So 2 times 1/2 or 1. Power 4 times 2. Power 4 times 2 is power 2. Cosine is 0. Power 3 times 2. 2 power 3. So it's the same as power 3, but it's negative in the second quadrant. So 2 times negative 1/2. Power 2 times 2 becomes pi. Cosine of pi is negative 1 times 2, negative 2. So let's write the pairs. Let's start with the first two. So 2, 0, along the 0, and you go 2 tick marks or 2 circles. The first one, the second. 1 and power 6. Locate power 6 and go with the first circle. 0 power 4. When R is 0, it's really the pole class, ultimately. It makes no difference. It doesn't matter what you have here. If R is 0, it's the pole. Now, negative 1 power 3. So let's locate power 3. Class power 3 on the positive side, power 3 on the negative side, the opposite side, okay? Because it's negative 1. So power 3 go in the opposite side. Power 2 up here is positive. Because it's negative 2, go down by 2, the opposite. So right here, everybody, if you just connect those two, you get that. If you continue, you get a rose. So this is what we had. If you continue. Okay, so just, maybe I put the arrow so you can see. So it's going this way, comes this way, this way, this way, going this way, going this way, finally this way. I hope you see the arrows. If you put that into a calculator, everybody, 2 cosine 2 theta, it creates the shape for you. Let me see if I can show you on a graphing calculator if possible. So mode, function, polar, graph, 2 cosine, 2 theta, and that's the graph. So as you can see, we have that, and then the rest of it. So graphing calculator also showed you that. Now, a couple of things I want to add. Rose curves are characterized by equation of the form r equals a cosine n theta, r equals a sine n theta, and of course, a can't be zero. And have graphs that are rose shaped. If n is not equal to 0, is even, the coefficient of theta, the rose has 2 times n petals. If n is not equal to plus minus 1 is odd, the rose has n petals. In other words, n is odd, that is the number of petals. If it's even, times 2. Then we have others. The Lemniscates are characterized by equations of the form r squared equals a squared sine 2 theta, r squared a equals a squared cosine 2 theta. Of course, a can't be 0, and have graphs that are propeller shaped and so on. So I'm going to show you a couple of pages of graphs reminding you of a line, y equals tan alpha x, theta equals alpha, a vertical line, x equals a, r cosine theta equals a horizontal line, y equals b, r sine theta equals b. And we know a circle has equation x plus x squared plus y squared equals r squared, in this case a squared, where r equals a centered at the pole or the origin. If we have r equals plus minus 2a cosine theta, or x squared plus y squared equals plus minus 2ax, it the center is along the x-axis. If it's plus minus 2ay or plus minus 2a sine theta is along the y-axis. R equals a plus minus a cosine theta, that's a cardioid, or a plus minus a sine theta, okay, where a is positive, and it's the lemicon if b is between 0 and a in this format, and it has an inner loop when 0 is less than a less than b, and so forth. And as far as the rows is concerned, it was explained already. And again, the cardioid, r equals a times 1 plus cosine theta, or 1 minus cosine theta or sine theta, where a is of course positive. The graph of the cardioid passes through the pole, okay. Lemicons without an inner loop are characterized as the following, where a is positive, b is positive, and a is larger than b. So this is just a synopsis of the graphing, everybody.